Hello guys, I'm Guru Prasad. Today we are going to explain about some of the most important topic related to analysis and design of algorithm. So that is the traveling salesman problem. So let's begin the video. First, we'll go into the introduction to TSP, that is introduction to traveling salesman problem. The traveling salesman problem is a classic algorithm problem in the field of computer science and operation research. It focuses on the optimization, especially finding the shortest possible route visiting a set of cities and returning to original city. TSP is a NP hard problem and it is meaning no efficient solution is known for the large instances and making it an significant subject of a study. So let's move on to the importance of TSP. What are the importance of the traveling salesman problems? The traveling salesman problem has the practical application in the logistics, planning, and the manufacturing of the circuits. Solving TSP can lead to significant cost and reductions and efficiency improvements in the various industries. So the understanding TSP also contribute to the development of the algorithms applicable to another combinatorial optimization problem. So this is all about the importance of the TSP. So the applications of the TSP can be used in a mechanical arm and it can be used in an integrated circuit. So the problem definition is the TSP instances consist of a list of cities and the distance between each pair of the cities. The objective is to determine the shortest route that visits each city exactly once and returns to the starting point. TSP can be formulated mathematically using the graph theory and where cities represent the nodes and the distance represent the edges. So next, the different types of the TSPs are the classic TSP involves the finding the shortest Hamilton circuit or the weighted graph. The variants include the asymmetric TSP where distance between the cities are not symmetric and the multiple salesman problem. Each variant introduces the unique challenges and can require different algorithm for the effective solutions. So TSP algorithms overview. The various algorithms exist to tackle the TSP ranging from the exact methods to approximation techniques. So the exact methods include the brute force search, branch and bound, and dynamic programming. Approximation algorithm provide near optimal solution for more quickly, such as the nearest neighbor and the genetic algorithms. So next, brute force approach. The brute force method involves the generating all the possible permutations of the city routes. This algorithm guarantees the optimal solution but is computationally infeasible for the larger data sets. It is complex. Its complexity is O of n factorial, making it practical only for the small instances of the TSP. So next, we'll move on to the dynamic programming. Dynamic programming can solve the TSP using the held cart algorithm, which break down the problem into the smaller sub-problems. It is also called as a divide and conquer rule. So this approach significantly reduces the time complexity of O(n) square, so making it feasible for the moderately sized instances. So next, we'll move to the branch and bound method. The branch and bound technique systematically explores the branches of the solution space. It uses the bounds to eliminate the branches that cannot be produce the better solution than the current best. So this method can be more efficient than a brute force, but still struggles with a very large data sets. So this is all about the branch and bound method. So this is one of the another symmetrically search of the solution space method. So selection options are the next E node is FIFO and the max profit. The leave node is list queue. Queue in with the help of queue, it will be execute. So it will extract the node in the same order as they is put into it. And the least cost is or the max profit is the least node is minimum heap or the maximum is the next E node, the leave node with least cost or the maximum profit. So the each leave node becomes the E node exactly once node. So next, approximation algorithms. Approximation algorithms aims to provide the solutions to close the optimal in the reasonable time frame. The nearest neighbor algorithm is simple heuristic that builds the tour by visiting the nearest unvisited city, while fast approximation method do not guarantee optimally and especially in the complex instances. So approximation algorithm will be works like this. So it is a row of an approximation algorithm. So next TSP NADA, that is the main thing. The AD is like analysis and design algorithm is a high-level programming language known as its strong typing and reliability. Implementing the TSP algorithms in ADA allows for the efficient and robust solutions due to its structured nature. ADA capabilities make it suitable for developing the complex algorithms like those used for the solving TSP. So this is low-level language, medium language, and a high-level language. The binary code will be and machine learning code will be used for the low-level language. Assembly language or C, C++ is used for the medium-level language, and COBOL, Pascal, Python, and Java, which will be used for the high level language. So next, setting up the problem in the ADA. To implement the TSP in the ADA, we start defining the structure of the cities and the distances. We can use the arrays and or the records to represent the adjacency matrix of the distance between the cities. And a proper data structure design is crucial for the algorithm's implementation and the performance optimization. So for the first one is example code brute force in IDEA. An example for the IDEA code for the brute force approach involves the generating the permutations of the city indices. The algorithm calculates the total distance for each permutation and tracks the minimum distance found. And while straightforward, this implementation is limited to small datasets due to its factorial time complexity. So next one, the example code for the dynamic programming is the dynamic programming approach can be implemented using a recursive function with a memoization. ADA strong typing ensure that parameters and return the type are clearly defined, enhancing the code reliability. This method is more efficient for the moderate size instances and can be adapted for the various TSP variants. So next, testing and validation. After implementing the TSP algorithms in the idiot throughout the testing and essential for the ensure the correctness and the performance, we can validate our implementations against the no for the solutions or the small test cases with a calculable outcomes. Performance profiling helps identifying the bottlenecks and optimize the code for the larger instances. So now final conclusion about the TSP, that is traveling salesman or the Hamilton cycle formation or traveling salesman problem is the traveling salesman problem is remains the significant challenge in the computer science and optimization. ADA provides the robust platform for the implementing the various algorithms to tackle the TSP effectively. Continued research and development can be lead to improved algorithms and more efficient solution for the real world applications. So if you want to know about more about the TSP, then you can further read. For those interested in the developer, like delving deeper into TSP, several resources are available, including the academic papers and the textbooks. So the online platforms and the forums provide supports and discussions opportunities for the ADA programming and algorithm development. So the exploring the advanced topics like meta-heuristics and further enhance the understanding and applications of the TSP solutions. You can read all the academic papers and textbooks. If you know about if you want to know about TSP in briefly. So this is all about the traveling salesman problem in the ADA. So I hope you guys enjoy this video. So please